Hello everyone, today we'll talk about the problem. Find the city with the smallest number of neighbors at a threshold distance. We're given an undirected, weighted graph as a list of edges. And we want to return the number of a city that has the smallest number of other cities reachable through those edges, whose shortest distance is at most some threshold that we're given. So in essence, we're interested in close neighbors of every node. We want to return the node that has the fewest close neighbors. If there are multiple such cities, so in order to break the ties, we want to return the one that has the biggest number. Of course, there is a very natural approach to this problem, since we can simply calculate the distance for every city to all the other cities, then count the number of cities that are reachable with at most the threshold that we're given, and select the appropriate city to return. And in order to calculate the distance from every city to every other city, the shortest path, there are many ways to do it. And in this problem, where n is up to 100, probably the best approach, and definitely the easiest to program and to remember, is the floyd-warshall algorithm. This is a dynamic programming algorithm that has a very simple idea, a very simple formulation. We start by just knowing, so we'll be maintaining the matrix of distances from one node to the other. At the beginning, we know, for instance, that every node can reach itself in 0 with a cost of 0. And also, whenever we have an edge, then those two nodes are connected by that edge, with the weight of an edge being the cost of that connection. And now, we can, for every pair of nodes and every middle node, we can see if it's better to travel first from so we have the pair of nodes I and j, and we can improve the distance between I and j by using k, by first going from I to k, and then from k to j. And of course we take the minimum because we are only interested in improving the distance. And if we loop over all the vertices, then it turns out that we will find every shortest path, so indeed the algorithm is correct. So this is very simple dynamic programming. And of course it's important, when you're implementing floyd-warshall, to remember that the order of loops matters. So this is the classic order. We first loop over the intermediary vertex, so this k vertex, and only within it we loop over all the pairs of vertices. Since if, for instance, you try to just go for I, for j, for k, that will calculate something, but it's not guaranteed that it will indeed calculate the correct matrix. So remember that this order is important. And of course, now that we have in our matrix the distances for every pair of nodes, we can just look at those distances that are not too big, count the number of those distances. So we just sum up the rows that were first mapped to be just booleans if indeed the distance is small enough. And now we have to return the number of the city that has the smallest number of reachable neighbors and break ties by the greatest number. So we will first sort by count, then by negative number of vertex, so that we can sort by one thing in ascending order, the other in descending order, which is the classic trick. By just negating the value, we can reverse the order of sorting. And of course, we have to return the final vertex. And as I notice here, so we take the minimum here. So that would be the pair of count of reachable neighbors and the number of the vertex. We take the number of the vertex, which is the second element, so element at index 1 from that pair. And of course we have to negate it, because we have negated number of vertex here in order for the sorting to be in the correct order.